All right, we are on the downslope of chapter 2, guys. And so, really, this is where we want to get to as far as day 7 is concerned. We want to be able to say, hey, I can work a proof that needs reasoning. With day 7 here, at this point, we should be able to say, I can work a proof that needs reasoning. So, for example, number 1, I can give all the reasons here. Now, hopefully by the end of day 7, we will also be able to say, hey, we can also make some statements and fill in some statements here, like on number 5. That's what we're going to try to get to by the end of today. So if you're not quite there yet to where you can fill out statements and you know what the next statement is going to be, don't panic. We're hopefully going to get there by the time today ends. But as we get into day 7, guys, you're going to see we're dealing still with geometric proofs. Today, the focus is going to be on complementary, supplementary, vertical angles, and linear pairs. So you can see today is going to be all about angles. All about angles today. And I want to remind you, I think this is something we don't really quite realize. We need to use what they give us. This is your hint, guys. When it comes to working these problems, they don't give you this for no reason. This is going to be your tools that we then are able to manipulate into figuring out what we need to prove. So we need to use what we're given. So for example, we know X and Y are complementary angles. So what that means is, that means these two angles are going to add up to 90 degrees. Notice that we're told the measure of angle X is going to be 3 times the measure of angle Y. So we'll call this 3 angle Y's. Yep, so whatever angle Y is, angle X is 3 times as much. Okay. And then check it out. X plus Y equals 90. We're just talking about a definitive statement here. If you were to look back, you would see that we're looking at the definition. If two angles are complementary, they add up to equal 90 degrees. That's all that's saying there. So we got the definition of complementary angles. Now we're told that angle X plus angle Y is 90. We're also told angle 3Y plus angle Y is 90. Wait, where'd that 3Y come from? Oh, wait. Angle X is really just 3Y, so we can replace what was X, we can replace with Y. And if we replaced it, we used substitution. And from here, guys, I know you can take it the rest of the way. So we combine like terms, 3Y and Y gives us 4Y. Combine like terms there and then divide to get angle Y is 22.5. Now, same strategy, guys, for number 2. Use what they give us. They give us that this line and this line are perpendicular, but they don't give us that we have a right angle yet. So we can't really draw that just yet. Now, angle 1 is going to be 48 degrees. That we do know. Okay. Now, I want to see if you guys can take this down to step 4. Try down to step 4. And I'll give you a hint. PQR is a right angle. That is not the definition of a right angle. If an angle is a right angle, then it measures 90 degrees. That's not what this is saying. So go ahead, guys, and give it your best shot. Just know that number 2 is not the definition of a right angle. Okay, so we've had a chance to see that very carefully. We're not using the definition of a right angle. We're using the definition of a perpendicular line. Perpendicular lines is what creates this right angle right here. And if that's the case, we then can say, oh, well, that angle is equal to 90 degrees. That's the definition of a right angle. And from there, we're going to start transitioning into using this picture over here, because we know if this is 90 degrees and angle 1 is 48 degrees, we can start doing some math to figure out exactly what we're going to have here. So what do you guys think we can do? If we know angle 1 is 48 degrees, what can be our next step? Oh, we can take this, plug it in for angle 1, and we know this is really 48 degrees plus angle 2 equals PQR. We just established that is 90. And we can use substitution to do that. And then you guys know the last step here. How are we going to solve for angle 2? Let's subtract. And so angle 2 is equal to 42 degrees. Now, page 2. I'm going to turn you guys loose on most, but not all of this. So we're going to get some practice in here. On number 3, I want you guys to try 2 through 4 for me, please. So number 3, 2 through 4, and again, remember, 1 and 2 are complementary angles, so we know these are going to add up to be 90. And then on number 4, remember that GB is perpendicular to GC. So in other words, GB and GC form a right angle. And on number 4, I'm going to let you guys try a little bit more. We're going to try, so we know we're trying steps 2 through 4 there. We're going to try 2 through 7. Dang, I know that's a lot. Big thing I want to point out, guys, and that we're going to talk about is be on the lookout for, remember, if words, then math, and we're talking definitions, we're talking definition, straight up. Straight up. Sorry, I'm so sorry. If we have math, and then in the next step we have words, that is going to be the converse of the definition. So keep that in mind, guys, as you're working through these. Definition is words then math. Converse of the definition is math then words. So go ahead and give these a shot. So let's look at number 3 first, guys. So we know that PQR, 1 and 2 are complementary, that's given. So that means 1 and 2 equal 90. That's definition. Remember, we had words then math. Words then math, we're talking straight definition of complementary angles. Well, then we're told that part plus part's going to equal the whole. That's angle add post. And how can we then say that PQR is going to be 90? How do we know that? Well, look back up here, guys. We're told that angle 1 and angle 2 adds up to be 90. Angle 1 and angle 2 are also PQR. So we can cut out the middleman and say that, oh, well, if 90 is really 1 and 2 and PQR is really 1 and 2, by the transitive property, PQR is really 90. These two really equal each other. And then from there, we got math and then words. And we're actually still on subject here of PQR being 90 and then that leading into a right angle. Don't forget, guys, if you see that, math then words, check it out. Converse, if an angle measures 90 degrees, then that angle is a right angle. That's the order we have this in. 90 degrees, right angle. This is converse of the definition of a right angle. Just be very careful on that. And then from there, we're told that we just straight up have QP. QP is perpendicular to QR. And if you look, once again, we're talking, we know it's going to have something to do with perpendicular. So let's take a look. And we can see here that if we're coming to a conclusion, the definition of perpendicular lines, then they form right angles. Well, that's not the conclusion here. It's the conclusion is that these two lines are perpendicular. Well, if we look at the Converse, if right angles are formed and those two lines, rays, segments, or planes are perpendicular, which is what is being stated right here. That's our conclusion. So that is the converse of the definition of perp lines. Let's see what you guys are thinking on number 4. So we are given that these two lines, GB and GC, are perpendicular. That means that angle 2 should end up being a right angle, but we have to prove that. So we're given words followed by words, which means we have a straight definition. The definition is going to be, if we have angle 2 as a right angle, that's the definition of perpendicular lines. Remember, not right angles. That is what we conclude from the definition of a perpendicular line. Then they form right angles. Well, then from there we go from words to math. So again, we have the definition. This time, if our conclusion is that angle 2 is 90 degrees, that's the definition of a right angle, that an angle equals 90 degrees. Okay, now we shift gears. You notice how we shift away from, like, these two are connected. Well, now we're talking, check this out. 4, 5, 6, and 7 are connected here. Check it out. They're all talking about AGE. So AGE is a straight angle. That's straight up words. That's the definition of a straight angle. Followed by math. Words then math. AGE is going to be 180. Oh, well, that's just the definition of a straight angle again. Again, that's hypothesis and conclusion all right there. If an angle is a straight angle, then its measure is 180 degrees. Bada boom. Boom, boom. Then we've got part plus part plus part equals whole. So angle add post. And then how do we replace all these angles with their values, or at least angle 2 with its value? We said earlier that angle 2 is 90 degrees. So angle 2 disappears, and we substitute angle 2 in with 90. Then we got 2 steps left, guys. What can we do here if we're trying to figure out that angle 1 and angle 3 are complementary? Well, in order for them to be complementary, doesn't that mean they add up to 90? Check it out. We have 1 plus 3 right here, but there's a 90 in the way. What would happen if we subtracted 90 over? So through subtraction, we subtract 90 over, and we can say that angle 1 plus angle 3 is really 90 degrees. And if that's the case, be careful here. We've got math, then words. If we've got math, then words, oh boy, that's going to be the converse of the definition of complementary angles. Math, then words, we're going to the converse of the definition. So let's pause, guys, and take a stretch break. Look at that deformed smile. All right, page 3. Now I'm going to give you a short but challenging problem to try here for me. It's going to be tough, but look for patterns, look for repetition, look for steps we've seen before, and also think about what they give us. We know B is a right angle. We know C is a right angle. And crucially, we know angle 1 and angle 4 are congruent. So it totally makes sense that we're going to try and prove that angles 2 and 3 are congruent. Because if we know the whole is congruent and we know these pieces are congruent, obviously we're going to be able to prove these pieces are going to be congruent. And so I'm going to give you guys a chance to start, and I'll give you a hint. We've got words to start, followed by math. So keep that in mind, and let's see what you guys get for number 5. Were we able to go 2 for 2 on number 2 and number 3 here? If we have words about right angles leading into math about angles being 90 degrees, clearly we're talking definition of right angle. If you have part plus part equals whole, part plus part equals whole, we're talking angle add post. And then finally, how are we able to say 2 is going to equal 3. Well, if you ever notice we go from math to math, a lot of times this property we're about to use is going to be involved right here. What do you notice? Well, I see we've got a lot of repetition here. We know that angle 1 is going to be equal to angle 4. We know that B and C are both 90 degrees. So if B and C are both 90 degrees, we know that we have angle B taken care of. C is 90 degrees. So these are really the same thing. So we can really say that if B and C are the same thing and 1 plus 2 and 3 plus 4 equal to the same thing, then normally we could say 1 plus 2 is the same thing as 3 plus 4, right? If 1 plus 2 adds up to be B, and we know that's 90, and 3 plus 4 adds up to be C, which we know is 90, then we know we've got 1 plus 2 equals 3 plus 4. But here's the thing. What do we know about angles 1 and 4? Well, we were given at the very beginning, these are congruent. So really, angle 1 and angle 4, that's just adding the same thing on to both 2 and 3. Eliminate those and you haven't really changed anything. And what do we find out? Through the transitive property, angle 2 is going to be equal to angle 3. All right. So here's going to be one of the most challenging problems we do today, guys. And actually, this is where I'm going to stop for today, at least, because I don't want to overwhelm you guys. I know we're running a little bit low on time. This video is going a little bit long, but we will get to the back page as well. I promise we'll get to that back page. But the big thing here is we got nothing, or at least that's what we think. What are we given? Well, we're given angle EFA. EFA is the same thing as angle 6. So these are congruent. And what we're trying to prove is that angle 5 and angle 1 are congruent. And if you notice, isn't this a linear pair? And isn't this a linear pair? Also, what do we know linear pairs add up to? Oh, that's right. That means this is going to be supplementary. And that means this is going to be supplementary. And if you recognize that, guys, you will have almost every logical step and reason ready. So let's start with what we're given. Angle EFA is congruent to the measure of angle 6. So we're given that. No sweat. So that's step 1 for both. Now, based off this, again, we're sticking with this concept here. We know angle 6 and angle 5 are a linear pair. We can say that 6 and 5 are a linear pair. And the reason we can say that is if you go back to our definitions, you'll see that the conclusion we can draw from that is the definition of a linear pair. Based off the definition of a linear pair, we know that 5 and 6 are adjacent to each other and they form a line. Check it out, adjacent to each other and they form a line. How about next up? What are you guys thinking? Step 3. Well, how about before we even worry about step 3, what else could we say is a linear pair? Well, how about angle EFA and angle 1? Aren't those a linear pair also? Heck yeah. So we can go ahead and take care of both of these. So here's the thing. You don't need an additional step if you're knocking out 2 exact concepts just with 2 different setups or 2 different positions. 6 and 5, EFA and 1, both those are linear pairs. So we can go ahead and label that at the same time. Step 3. You know what always follows a linear pair? Always, always, always follows a linear pair. Supplementary. Sup follows. Almost always. And it's always, we know 6 and 5, angle 5, are sup. We also know that angle 1 and angle EFA are sup. So again, guys, anytime you have linear pairs, that almost always leads right into having them also being supplementary if they're next to each other. Okay, and what lets us say that? Well, that's based off of the good old-fashioned linear pair postulate. And I'll remind you, these two usually follow each other. So these two usually follow each other. And then based off supplementary, what do we know they're going to add up to be then? Well, sorry, I'm running out of room here. Angle 4, we know that angle 6 plus angle 5 should be 180. And we know that angle 1 plus angle EFA should be 180. Okay. And what's that going to be based off of? Well, if we've talked about linear pairs and now we're talking about supplementary, that's straight up based off of, we're going words to math. Keep that in mind. Words to math. We know that is definition of supplementary. And finally, again, I apologize for running out of room here. Why did I put 5 there? That's 4. We know for option 5 here, think about it. If angle 6 plus angle 5 is 180, and angle 1 plus angle EFA is 180, then by the transitive property, we can cut out 6, we can cut out these 180s, they repeat, and we can cut out EFA, because we were told at the beginning, EFA is really just angle 6. Cut out the repetition, and what are you left with? Angle 5 is going to be equal to angle 1. And what lets us cut out the middleman and cut out the repetition? Transitive property. Whew. You want to talk about making a mess. That right there is making a mess. So I apologize for that. That is messy. So what your homework is going to be, guys, we're going to have some homework on the back page. I want to give you guys a chance for homework to do number 7 and number 8. Give me your best shot here, guys, and we will talk about these tomorrow. This is on page 4.